everyone, myself Rama. I am working as assistant professor in Mlritm college. Today's my topic is static class members in C++. Here in C++, we can declare the class members as static. When we declare the class members as static, that are called static class members. We can define class members as static using the static keyword. These members belong to the class itself. Whenever we declare the class members are nothing but variables and methods. When we declare the variables or methods in a class as static, that all belongs to the class itself only, rather than to any specific object of the class. Here, whenever we declare the class members as static, that are accessed by the class name only, that are belongs to class, that are not related to the any object of that class. Meaning only one copy exists for all objects. Whenever we declare the class members as static, that are created only one. There are no duplicate copies. Whenever we declare multiple objects to that class, but the static class members are only one copy is created. In C++, the static keyword can be applied to both the data members and member functions. Here a class is a combination of variables and methods. So here we can declare the variables as static and methods also static. Now let us see one by one. First one, static data members, means in a class the variables or static data members are declared as static. When data member is declared as static, only one copy of data is maintained for all objects of the class. When the class contains three objects, for example, class sample. Now there are three objects for this class, for object 1, object 2 and object 3. Here the variables are declared as static, for example static index. Whenever we create the three objects for this class sample, here only one copy of static variable is declared. We cannot create the multiple static variables for multiple objects. Only one copy of static variables are created. Now this static data members has certain special characteristics. First one, all static data is initialized to 0 when the first object is created, if no other initialization is present. Here in this example, the static variable is declared, but here we are not initializing the variable x. By default, the value of the static data member is 0. It is by default initialized as 0. Only one copy of that member is created for the entire class and it is shared by all the objects of that class. Here, there is no matter how many objects are created. Already we discussed here, there are three objects for this class, but the static variable int x is created only one copy. This only one copy is shared to all the objects. If the value is modified by any of, if the value is modified, that modified value is shared to all the objects which are created to that class. It is visible only within the class, but its lifetime is the entire program. Here, whenever we start the program, automatically the static variable is initialized in the memory. It is visible only within the class, but the lifetime of the static variable is entire the program execution time. So whenever we modify the value, that is reflected to all the objects. A static variable is normally used to maintain value common to the entire class. Whenever we modify the value, that is automatically reflected in the next cases also in that class. Static data members are not part of the objects of a given class type. Always the static data members are linked to class only, but not the objects. If there is any variable, for example, into y, it is non-static variable, but whenever we create the three objects, by using these three objects, we can access this variable y because it is non-static. But the static data members are created only one copy for the entire class. Here there is no matter of how many objects are created for the class. Now the declaration of the static data member is, here we use the static keyword, space data type, space variable name. Let us see the example, static int ABC. Here int ABC is a variable. Okay, it is declared as static, then it is called as static data member in a class. Note that the type and scope of each static member variable must be defined outside the class definition only. Here the declaration is possible within the class only, but we can define the static data members outside the class with the help of class name and scope resolution operator. Static data members are stored separately rather than a part of an object, since they are associated with the class itself. Here static data members are stored separately. Here the static data member is stored separately. Now when we consider this example, so one copy of y is created for object 1, next object 2 and object 3. But for these three objects, only one copy of static variable is shared. So here three objects share the common variable, that is x, because it is a static variable. Here we are not creating the separate static variable for the individual objects. Here only one copy of static variable is created. That single variable is shared by all the objects. Here that is mentioned here, static data members are stored separately rather than a part of an object, since they are associated with the class itself rather than with any class object. So static member is shared by all the objects of the class. Here the static member data member x, it is shared by all these three objects, but the static member is not created for each object. Only one copy of the static variable is created, that is shared by all the objects which are created for the sample class. Okay, this is called static data members. The static data members are declared by the keyword static. These are declared within the class, but we can define that static data members outside the class by using the class name and the scope resolution operator. Now here this operator is called as scope resolution operator. So here what is the use of the scope resolution operator? This operator, it is a link between the class name and the variable name. Means here this variable, right side variable is belongs to the left side class name. Here by using this scope resolution operator, we can easily identify that this right side variable belongs to the specified class name. So here we can access the static variables outside the class by using the class name and the scope resolution operator. Now here by using this syntax, we are defining the static data member outside the class. So here int is a data type, demo is a class name, and this colon it is indicated as scope resolution operator. Here ABC is a static variable. Here it is a static variable, demo is a class name, and here it is the static variable is declared with the value 10. Now this is called as defining the static data member outside the class. We are accessing outside the class. That's why we are using the scope resolution operator. From which class we are accessing that static member is defined by the class name. Static variables can be accessed by class name but not object. Remember this point. Always whenever we declare the class members, either data members or member functions, that are accessed only by the class name but not with objects. Okay, remaining all non-static class members are accessed by the object only, but in case of static members only, we use the class name. If you are calling a static data member within a member function, that member function should be declared as static. Whenever we want to access static data member within a function, that function should be declared as static only. Means the non-static functions cannot access static variables. Means here the static variables cannot be used in non-static functions. Let us see the example program. Here class demo. Here demo is a class. I declared one variable, static variable, that is ABC. This is called as declaration. This is called as declaration. Now this static variable is defined outside the class. Here defined outside the class by using the class name and scope resolution operator. Here why we are using scope resolution operator means we are accessing the variable from which class, that is defined, that is explained by the scope resolution operator, because here the class is open here and the class is closed here. So outside the class we are accessing the ABC variable with the help of class name, because whenever we use the multiple classes, we have to explain clearly to the compiler from which class we are accessing the variable. Okay, that is defined by the scope resolution operator. Here the ABC data member is belongs to the class demo, that is explained by the scope resolution operator. Okay, in main function we are printing the value of ABC. Now here outside the class, the static data member is initialized as 10. So when this line is executed, automatically we will get the output, the value of ABC equal to 10. So here in the class, the static variable is declared with the keyword static, but that is initialized outside the class only. Remember this point. Now this is called as static data members. So the static data members are used in static member functions only. Like a static data member, we can also have static member functions. A static member function in C++ is a function that belongs to the class rather than any object. Already this point is discussed in the previous slides. So whenever we declare the variable or function with the keyword static, that are belongs to the class only. Okay, but not any specific object of that class. It is declared using the static keyword inside the class definition. Means we can define the static member functions inside the class. Okay, let us see the characteristics. The static member functions can be called without creating an object. Here we can access the static member functions by using the class name only, but not with objects. So static function can have access to only other static members. A static function can have access to only other static members. Here, whenever we use the static variable, it should be accessed in the static member function only. That static member function should also declare within the same class. The static function, member function, does not access non-static variables. Static member function can be called using the class name only. Here also we use the same concept. Whenever whatever it is declared as static, that can be accessed using class name only, but not the object. Here the syntax is class name, scope resolution, operator and function name. So here we are defining the function outside the class by using the class name and scope resolution operators. Okay, here we use the same concept for static data members as well as static member functions. Let us see the example. Here the class name is demo. Here one variable is declared as static, that is x variable, and the one function is declared as static void function. Here variable is static and the function is static. So this static variable can be used in static function only. So for example, I declared one more variable int y. It is a non-static variable. The static function does not access the non-static variables. Static function, it accesses only static members. But whenever we use the non-static member function, it accesses both the static and non-static variables. Now, this variable is defined outside the class by using the class name and the scope resolution operator. So here variable is defined outside the class with the help of class name and scope resolution operator. By using the same concept, we can execute the function. We can call that function by using the class name and scope resolution operator only. So whenever we use this class name and scope resolution operator, it means that this function, it belongs to this class demo. So here, and this function is not a non-static function. It should be a static function. If it is a static function, then only we use the class name and scope resolution operator. For example, here there is one more function, void show. Now it contains cout. Now here I want to print welcome. So here there are two functions. One is static function and second one is non-static function. Here if you want to print a static variable x, that is not possible. We can access this one and here also we can access y. But this static function, it can access only static variables but not non-static variables. So here if you want to execute show function, first we have to create a one object demo d. By using that object d dot show, we can call the function. So whenever we use d dot show, then it calls the non-static function. It will be executed. But if you want to call the static function, we should use class name and scope resolution operator. For non-static functions, there is no need of the class name and there is no need of scope resolution operator. By using object, we can execute the functions, non-static function. Okay. Now let us see some points regarding to the static class members. Here, static class members means variables and member functions are declared with the keyword static. Static methods can access only static variables, but non-static methods can access static and non-static variables. Whenever we use non-static function, it can access static as well as non-static. Both can be accessed in non-static method. But in static method, we can access only static variable. Next, static variables and methods are accessed by using the class name only. So whenever we observe the previous example, here x is a variable, static variable, and function is a static member function. Both are accessing by using the class name and scope resolution operator. But this non-static member function can be accessed by using the object. But non-static variables and methods are accessed by using objects only. Static variables are common to all objects of the same class, but non-static variables are separated to each objects. Okay. For example, this demo class, I created 3 objects: object 1, object 2, and object 3. For example, D1, D2, and D3. So here 3 objects are created. When we take the non-static variable, for every object, one y variable is created. But only one static variable is created. This only one static variable is shared by all these 3 objects. Okay. So when this value is modified to, for example, 20, the previous value is 10. Now it is modified to 20. This reflected value is shared by all the objects. So whenever we start the execution of a program, this variable, static variable, is visible within the class only, but this lifetime of the static variable is entire the program execution time. That is the scope and lifetime of static members. The last point is static variables are known as class variables, but non-static variables are known as instance variables. Whenever we create both static and non-static, the static variables are called class variables, but these non-static variables are called as instance variables. These are called instance variables and these are called class variables. This is about static data members and static member functions. Here, remember one point: whenever we use the static before the variable or function, that are accessed by the class name but not with object. And second point is the static members are created only one copy, that is shared by all the objects which are created for that class. This is about static members and member functions. These are some important points regarding static class members, and these are the references. Thank you.